we're going to learn how to solve quadratic equations by completing the square. If you're watching this video, you should already know how to change this equation from standard form to graphing form by completing the square. The only difference to solve an equation is that there is going to be an actual y value. I'm going to randomly choose the value 5, and then we'll be able to solve that equation. If you think about this graphically, what I'm trying to solve is when does that parabola have y values that equal 5? And it's at these two x values, so we're looking for those two x values as our solution. A lot of times you would see here where the 5 is, a y value of 0, because a lot of times we're curious, where does this quadratic equation equal 0? That would give you the x-intercepts, and that's often the solution to many contextual problems. But right now we're going to look at when it equals 5. The first step is to think about this visually in terms of an area model. You can actually draw the area model or just think about it. We knew that it would be a perfect square if we got x plus 3 and x plus 3, because that way we get the 3x and the 3x for a total of 6x. So you can always divide that middle number by 2. If it's odd, you just end up with a decimal, and then you get the two sides, x plus 3, x plus 3. Here we have x squared. And then here we've got 9. We're supposed to have a 9 for it to be a perfect square, but we only have 2. So we need to add 7 to this side to get that perfect square. Well, that means we need to add 7 to this side to maintain balance in the equation. I'm going to pause the video and rewrite my new form perfectly. Now that we have 12 equals x squared plus 6x plus 9, it's the same equation that I started with on the previous line. It just looks different. And it allows us to factor the right side into the quantity of x plus 3 squared. We've made that perfect square. Now you can just solve for x. It's two simple steps. Square root both sides and subtract 3 from both sides. As a reminder, when we when we square root, we get the plus or minus square root of 12. And the last step is subtract 3, so negative 3 plus or minus the square root of 12 is the point on the parabola, if we look at our picture again, where the y value equals 5. Those are my solutions.